Then we'll see how to control the usage of keys here. Basically, if there is no limit set to the key usage of keys, you will know the keys can be used in different ways. So that is one advantage. So there should be limit for everything. So how to limit the usage of controlling keys? So we'll see the concept of key hierarchy and the use of automated key distribution techniques greatly reduce the number of keys that must be manually managed and distribution. This is one of the advantage listed here, advantage of key hierarchy. If we are using the automated key distribution scheme as well as key hierarchy, it basically reduces the number of key usage. That is, size of key will be reduced with these two concepts. If the size of key is actually reduced, you can implement that in the higher plain text also by using different techniques. That is one part. It is also it also may be desirable to impose some control on the way in which automatically distributed keys are used. So basically, controlling key usage depends on how the key is being used in the system or the process. If I tell with respect to encryption part, a key is being used with the help of which I'm encrypting some data. So at that time, the difference happens there. If I'm speaking about decryption, a key is being used to decrypt data. Both cannot be seen, but the common thing is your key, but the key is being used in different ways, encryption as well as decryption part. You can They have given one example here. In addition to separating master keys from session keys, we may wish to define different types of session keys on the basis of use. So it depends. The keys are basically defined, or the definition of key depends on how the keys are being used in the process or in the model, depending on used for encryption or decryption part. So this is how I can limit the usage of keys. How the limitation is been provided by specifying the key size, that is one thing, or else you can actually provide a limitation by two techniques. One is hierarchy key as well as key distribution techniques here. So this is how the controlling usage of the key is being initiated. So there are some drawbacks with respect to key controls. Associated tag with each key. So this was the concept of controlling key usage. So we'll see how the keys are actually being controlled. Here actually your DES algorithm comes into existence. So basically with the help of DES algorithm, this is taken as a tag here. So tag in the sense, basically whenever you are passing a key, it will move on with a tag. Tag in the sense representing that particular key. I am representing the key with a tag there. So for use with DES and makes use of extra 8 bits in each 64-bit DES key. In your syllabus, basically they have specified what is the key should be used with while you are working with respect to key controls. Basically, if you are using any key controls here, it will come with respect to some tags here. They have specified the tags. What kind of tags you are using here? The tag is used. The tag used here is your DES tag. So basically, with respect to key control, the tag we use is your DES tag. They are specified how many types of bits you have to use. Basically, DES key uses 64-bit data. In addition to key controls, there is extra 8 bits added to it. So finally, what is your key size? 64 plus 8, it is actually 72. Okay, that is the size of the key you can use here. So I can say I am controlling the key now. So two different ways I am controlling. One is by specifying a tag. The another one is by adding extra 8 bits to your initial key bit. Okay. Then the 8 non-key bits ordinarily reserved for parity checking form the key tag. So basically you can specify the key tag, or else you can leave up to the model to specify the key tag. You can see how the key tag is being generated based on the non-key bits, that is actually your parity bits, checking for the key tag, that is with the help of 8 bits. You are adding extra 8 bits, no? So those are actually parity bits which are actually ignored sometimes. So with the help of that, you can generate the key tag. Because the tag is embedded in the key, it is encrypted along with the key when the key is distributed, thus providing protection. That is, what is the usage of using these 8 bits? One usage is generating a tag. Second usage is whenever a tag is being generated, it is actually put up in some keys. That is, when the tag is being generated, it is actually linked to a key with the help of encryption part. Whenever you want the key, you can use the key and provide a distributed format for that particular key. That is, you can distribute the key throughout the model. So if you are distributing the key, the same key with the tag throughout the model, I can say huge number of security as well as protection is being involved there. So that is the concept of key control. So we have some disadvantages, some drawbacks with respect to key controls. We'll see the tag length is limited to 8 bits, limiting its flexibility and functioning. As we are including extra 8 bits, which basically tells you the length of the tag is actually limited to 8 bits only. So this is one of the important drawback, because if you are limiting the length of the tag bit, basically the functionality as well as the flexibility of the model reduces that. Then, because the tag is not transmitted in clear form, it can be used only at the point of decryption, limiting the ways in which key can be used as well as controlled. So you can see directly we are not transmitting the tag. We are transmitting the key with the help of tag. So this is one of the disadvantage here, because there is no clarity provided about the tags here. So I can use such kind of keys only at the point of decryption part. That is, whenever you want to decrypt the data, I can use such kind of keys with the tags, which basically provides you some limitation. What kind of limitation it is providing, how the key can be used as well as controlled here. So with the help of drawback, you are knowing how to control your keys there. So this is one of the simple concept of controlling the keys. So this is the representation of key controls. So these are two different models we'll be using in key controls. One is control vector encryption as well as control vector decryption. We'll be using a vector concept here, that is with respect to encryption and decryption part. First, we'll see what is control vector encryption. In control vector encryption, two important points you need to remember. One is your control vector as well as your hashing function. So with the help, this actually control vector is actually one of the input passed to your encryption function. So we'll see how this works. If you know the encryption part, one and the same applied here as an decryption part. Okay. There for this encryption function, there are a huge number of inputs provided here. One is your control vector, master key, session key. Okay, these are the three different inputs you are passing to your encryption function. But these inputs are not directly passed to your encryption function. You can see I am filtering this input with the help of hashing function. What basically hashing function does is it basically takes the input. What input? Control vector input, and it is actually converted into one function and sent to the master key terminator. Basically, this symbol is being called as master key terminator, who basically filters master key. Whatever the key it is being required from master key is been filtered and been sent to the encryption function. So it will take the function of control vector as also another input, with the help of which another key is being generated. You can see this output, whatever the a master key generator's output generator, or it is taken as terminator also. The output of master key generator is a key. Okay, that key is sent as an input to your encryption function. So what are the usage of this control vector is? Control vector is one kind of input which is actually provided for your encryption function. But control vector, what is the usage of such kind of input? So if I am passing control vector as an input to your encryption function, the security of encryption increases there. Encryption data increases there. So basically, that was one input, that is with the help of key. As we all know, the input for your encryption algorithms is your key as well as plain text. So with the help of session key, I am generating a plain text, that is with respect to session one, considering one session, a key is being generated, which is actually taken as an input for your encryption function. So what is the output of encryption function with respect to key is your encrypted key, that is your encrypted session key. Now you got encrypted session key. That was about your encryption part. Now let's see what happens in decryption part. In decryption, what happens basically, as we know the working of decryption, the encrypted data is converted to your what? Decrypted data. Basically, we'll see here with respect to decryption part, same concept works here. Input is taken as a key, and another input is your ciphertext, that is output of your encryption function, encryption session key that has been given here. So if I pass this as an input for your decryption function, finally you will get a session key. So what is the agenda? We are generating a session key. So this concept is actually included in your part, that is your key controlling part, where with the help of controlling of different inputs as well as outputs, you are generating a session key. You should remember two different parts, that is control vector encryption as well as control vector decryption, with the help of which you are generating a session key. Okay, this was a simple concept.